Good morning. I'm going to do my lesson on Vertex Form Day 2. How does Vertex Form help me? What does the A do? Okay, so hopefully you remember from the last lesson that Vertex Form looks like the following. I'm just going to write it right above here so that you can see. It's y equals, and then it's an A, and it's x minus h squared plus k, and h comma k is the vertex. So if you look at this, it says to type this into your calculator, and it's actually already written in vertex form. So I'm going to do that. I'm going to plug it in exactly in my calculator as I see. So I have 2 parentheses x minus 1 close parentheses squared plus 11. And I'm going to generate a table. And you can see the table to my right over here. I'm just going to scroll down so I could see a little bit better. So even if I wasn't looking at my table, which I can certainly look at my table and figure this out, if you look at your table, can you figure out who the vertex is based on this? Do you see a repetition over there? So hopefully you recognize that the vertex is 1 comma 11. And you can see that here on the table where it shows change in pattern in there. But if you didn't know that, let's say we go back up to here. We know that the inside lies, so if it says -1, it's +1. Outside tells the truth, so that's +11. So again, it's opposite x, same y. Identify the y-intercept. That's, if you take a look, that's over here where you're looking for the 0 value. So it's 0, comma 13. Is it concave up or concave down? Well, let's look at the A. The A in the front is positive, so therefore it is concave up. Is it a max or a min? If it's going up, it looks like this. Therefore, it needs to be a min. Identify the lead coefficient. In that case, or in this case, it is a 2. So, oops, that looks terrible. All right. 2. So it says, what is the pattern of change? So if the lead coefficient was 1, remember it went up by 1, up by 3, up by 5 on each side. So if I double those numbers, instead of going up 1, 3, 5, if I double them, it's going to go up 2, 6, 10, 14, etc. Okay. So we've answered all of those questions. So let's move on to the next slide. So now it says graph this function. And again, I'm going to use my calculator and I'm going to plug in 2. Notice this time it's written in standard form. Hopefully you know the difference between the two now. This is standard form versus vertex form. 2x squared minus 4x plus 13. I'm going to hit second graph. I'm going to generate a table. And if you can look, there's my table on here. But you should be looking at yours. So if I was going to put this in vertex form, I have to first move the constants. So I'm going to try and do this in this tight little spot here. And I get y minus 13 equals 2x squared minus 4x. So the first thing I have to do is I have to rip out the GCF on the right before I can complete the square. So I'm going to rewrite this. I'm going to move up top because I get So y minus 13 equals, and I'm going to rip out the GCF of just the 2. I'm going to leave everything else. X squared minus 2x. Because in order for me to complete the square, I need to have a lead coefficient of a 1. So if I pull out the 2, that leaves the inside the parentheses, the lead coefficient is a 1. So now this middle term, we call it the B term, is -2. I'm going to divide it by 2 and I'm going to square that. -2 divided by 2 is -1. -1 squared is 1. So I'm actually going to add 1 here and I'm going to close the parentheses. So normally we'd like to just add 1 on this side and that would be great. But in reality, this is the hard part here. Do you see the 2? Well, if I was going to distribute that 2, it's really 2 times 1, which is +2. So I'm actually going to add 2. So that's a hard trick to learn there. So now I have y minus 11 equals 2. And then I can complete the square here. This is x minus 1 squared. Then I'm going to add 11 to both sides. and I get y equals 2 parentheses x minus 1 squared plus 11. So that is now in vertex form, so I'm going to write that here. 2x minus 1 squared plus 11. So let's actually graph this. I'm going to graph it using the vertex form just because I feel like it. So the vertex of this, in case you don't know, I don't care whether you look on your calculator or you look here, it's 1 comma 11. So that should actually look familiar. I think it is the same as the do now. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, the lead coefficient is a 2, so I'm going to go up by 2 on each side. And then I can't even do anything else because the next one will be up by 6, and it doesn't do that. So if you look at this parabola, do you notice it's a little narrower than the parabolas we've drawn before because it's increasing really quickly. So that's what that 2 is actually doing. That's making it more narrow. What is the A? The A is a 2. It's a concave up or concave down. It's concave up. What is the pattern of change? It's up by 2, 6, 10, 14, not the 1, 3, 5, 7 that we know. How is this equation similar to the do now? It's actually exactly the same. It's the same equation. So we got this here. Once we converted it into vertex form, it looks exactly like the do now. This is the standard form of that equation. Okay, let's move on to the next slide. All right, we're not going to do these on our own. We're going to do them together, even though it says OYO. Write the equation in vertex form. So it tells you first to remove the constant. So I think I'm going to do all my work down below because I know there's line by lines here, but I'm not sure with the stylus I'm going to be able to, let's see, maybe I'll try. Okay, I'm going to use green because I feel like it. So if I'm going to remove the constant, I'm going to add 1 to both sides. So I get y plus 1 equals 3x squared minus 6x. All right, factor the lead coefficient. So I am going to do that. I'm going to do y plus 1. And I'm going to equals, and I'm going to rip out just the 3, x squared minus 2x, so I can complete the square. So again, my b term is negative 2. In this case, I'm going to divide it by 2, and I'm going to square it. That comes out to be a plus 1. So I'm going to do the plus 1 here. And again, I am not going to add 1 on this side, even though I want to. Instead, I'm going to multiply this and this. See how it says multiply by coefficient? So I'm going to do that. So technically, I have to be adding 3. So now I get y plus 4 equals 3 parentheses x squared minus 2x plus 1. Okay, on the next line, it says factor the perfect square. So I'm going to get y plus 4 equals 3 parentheses, and this is x minus 1 squared. And then I'm going to solve for y by subtracting 4 on each side. And I'm going to get y equals 3 parentheses x minus 1 squared minus 4. All right, so a couple of things we could talk about. This is the vertex form. Who's the vertex? Nobody's asking me this, but I'm asking you this. I'm going to say the vertex should be, hopefully you know in your head, it's positive 1, comma, negative 4. Looking at the A, which is 3, it's a positive number. Is it concave up or concave down? The answer is concave up. Is it a max or a min? It's a min if it's concave up. The pattern of change, instead of being 1, 3, 5, 7, if it's 3, I'm going to triple that. So it's going to be 3, 15, no, 3, 9, 15, 21. Let's take a look at the next slide. Okay. Answer the following questions. Oh, yeah, they're asking me these questions. Oh, totally didn't see that. Okay, who's the vertex? So the vertex is 1, negative 5. Identify the y-intercept. So see this question? This question I really can't answer when I look at the vertex form. What I need to do is I need to actually plug the equation. I'm going to go back for a second. So I'm going to plug in this equation. Oh, I actually don't really have to. I just realized it because it's in standard form. So I could actually see the y-intercept here. That's going to help me. And it's going to be 0, negative 1. Okay. You and I discussed this. It's concave up. Is it max or min? Min. The lead coefficient was 3. What is the pattern of change? 3, 9, 15, 21. Which question can you answer from both vertex form and standard form equations? So there's a lot of things that I can answer from that. I can answer who is the lead coefficient. I can answer concave up, concave down, because I can just look at the A term. After I know that, I could do max or min. I can figure out the pattern of change. And the reason why I could do that is the lead coefficient. And for both of them, I could probably do the axis of symmetry. I think it's a little easier in vertex form because it's just x equals h. But if you did negative x equals negative b over 2a, you could find that as well. All right, let's move on to the next slide. All right, now it says graph the function. So right away I am looking and I notice that the lead coefficient is a negative 2. So I'm going to use my calculator and I'm going to plug this in. And plug in negative 2x squared minus 12x minus 10. And I'm going to generate a table. Hopefully that's going to help me find some points. So I definitely found some points here. It looks like the vertex is negative 3, positive 8. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. I think it's right at the top. So just a quick question for you. If it's a negative coefficient, is it concave up or concave down? Hopefully you know that means it's concave down. If the lead coefficient is like 2, this case is negative 2, it's going to go up by 2, or down by 2, actually, I should say, and then down by 4, 1. I'm sorry, not 4, 6, 2, 6. So if it's 1, 3, 5, it's 2, 6, 10. I have to double this. So let's say 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And again, your parabola is going to look a lot better than mine. And I'm just going to call this f of x. So to put this in vertex form, let's actually see if we can do that. So I think I'm going to do it up on the right-hand side here. I'm going to erase this so I have a lot of room. And I'll change the color. So I have f of x equals negative 2x squared minus 12x minus 10. Okay, so the first thing I have to do is I have to move the constant, so I'm going to do that. Again, it's pretty annoying to write f of x, so I'm just going to make it into y. So I'm going to write y plus 10 equals negative 2x squared minus 12x. All right, so we really do want a lead coefficient of 1 when we're completing the square. So I'm going to rip out negative 2. So I have x squared plus 6x. So the b term I'm going to write down here is 6 when I divide it by 2 and I square it. I get plus 9. That's what I'm going to write here. So over here, I'm going to stop myself. I'm not going to write plus 9. Instead, I'm going to multiply by this coefficient, and that gives me minus 18. So that is what I'm going to do over here. I'm going to write minus 18. That was quite tricky. So I have y minus 8 equals negative 2. And if I factor this, it's x plus 3 squared. If I add my 8, so I'm going to write it over here. I have negative 2 x plus 3 squared. And then I have plus 8. So I already know what the vertex is by looking at this, but let's go look at the vertex form. And if I say to you, inside lies, you're going to say instead of plus 3, it's minus 3. Outside tells the truth, so it's positive 8. So is it at negative 3, positive 8? Yes, it is. What is the A? If I look at the lead term, either here or here, the answer is negative 2. Is it concave up or concave down? This time it is down. What is the pattern of change? We talked about that earlier. I guess if you want to, you can put negative signs in front of it just to show it's down 2, down 6, down 10, just because the lead coefficient is negative 2. How is the vertex similar to the equation after completing the square? So it's the opposite x, same y, or as you like to remember, or I like to remember, inside lies and outside tells the truth. Let's move on to the next one, onto silver. Let's see what we have here. This time it says write in vertex form. So I'm going to do it up here. Y equals 2x squared minus 4x plus 5. So just be a little careful because the lead coefficient isn't a 1. So again, I'm going to subtract the constants. Y minus 5 equals 2x squared minus 4x. I want to have a lead coefficient over here of 1 to complete the square, so I'm going to rip out 2. To complete this square, the b term is negative 2. I'm going to cut it in half, and then I'm going to square it. So I'm going to add 1. Again, be careful what you're going to add on the other side because you have to multiply by the coefficient. So I'm going to actually add 2. So I'm not adding again here because I added it technically. I put a plus 1 here, and that's 2 times 1 is 2. So I get y minus 3 equals 2. And then if I complete the square, it's x minus 1 squared. Add 3 to both sides. And then in vertex form, this is what it looks like. 2 parentheses x minus 1 squared plus 3. If I knew that, and I didn't use my calculator at all, so I just converted it, what is the vertex? The answer is 1, 3. Again, opposite x, same y, or inside lies, outside tells the truth. Who's the y-intercept? So again, from vertex form, I really can't find the y-intercept, but they did give me standard form, so this is my y-intercept here, which is 0, 5. Concave up or concave down, the lead coefficient is a positive 2, so it's concave up. Max or min, it's a min. Who's the lead coefficient? Positive 2. What is the pattern of change? It's going to be 2, 6, 10, 14 from the vertex. Okay, so silver friends, I'm done. Please try your homework. That's on vertex form 2. Gold friends, I'm going to move on to the next slide. All right, so gold, let's see what we could do here. So for this one, lead coefficient is 7. That should be interesting. Okay, so I'm going to rewrite that up here. I'm going to add 13 to both sides. And I'm going to get y plus 13 equals 7x squared plus 9x. Okay, so we do need a lead coefficient of 1. So I do have to rip out a 7. This is going to get ugly. Bear with me. This is why it's gold. So this is going to be 9/7. So then I'm going to take my 9/7 over here. I'm going to divide it. Ooh, that's wrong. Got ahead of myself there. 9/7, and I'm going to divide it by 2. So 9/7 divided by 2 is the same as 9/7 times 2, which is 18/7. Am I doing that right? Let's see. Let's use my calculator because I don't want to make this wrong. So on my calculator, I'm going to plug in parentheses 9 divided by 7, close parentheses. I'm going to divide that by 2. And it gives me this crazy decimal, which I'm then going to square. So let's see. And I'm going to change it back into fraction. I could do the math key, or I could do so it's 9/14 is what it's equal to. So I'm basically going to square that. I haven't even squared that yet. Oof, okay. So when I square that, let's see, 9 squared is 81. What's 14 squared? 14 squared is 196. So I'm basically, okay, still have to multiply this by the coefficient. This is so messy. All right, so I'm going to plug in my calculator. 81 divided by 196 in parentheses. I'm going to times that by 7. And that gives me, as a fraction, 81/28. So I'm going to add 81/28 to the side. So I'm going to get y. I'm going to add 13 to that. And I get plus 445/28, that's what my calculator says, equals 7 parentheses. So in here, when I factor this, it's basically x minus 9/14 squared, because it's whatever this b thing was. So then I'm going to subtract 445/28 from each side. This is ugly. And I'm going to write my final answer down here. I'm going to write y equals 7 x minus 9/14 squared minus 445/28. Ugh, ugly. Okay, who's my vertex? Inside lies, so it's positive 9/14. Outside tells the truth, so that's negative 445/28. Identify the y-intercept, which is here, 0, negative 13. Concave up or concave down, lead coefficient's positive, so it's up, max or min. Lead coefficient is 7. What is the pattern of change? So normally the pattern of change is 1, 3, 5, 7. If I times it by 7, I'm going to get 7, 21, 35, 49. All right, so that was kind of interesting. A little harder with all these messy fractions, but still doable, as long as you understand the concept of how to put something in vertex form. Just to recap the big idea, the A is lead coefficient. It multiplies the pattern of change. So the A definitely is going to change what it's going to look like here. That's it. You guys can start your vertex day 2 homework as well. Awesome. Bye-bye.